Okay, this chapter is chapter 6 out of Starkey. It is the assessment of posture. Throughout the program, you are going to have posture analysis covered several different times. The body all works together, so yes, this is upper extremity evaluation. So we will be focusing on upper extremity posture, but the effects of the lower extremity on the trunk and the upper extremity, they're all there. And so we have to all kind of look at it together. So if you already had lower, I think you did a lower extremity analysis. We're going to do same kind of thing in this class. And then next semester, we're also going to do full body posture. Again, very similar content, just looking at it from a different angle in head and spine. So this is a really important chapter. This is a really important concept, assessment of posture. It's good to be good at it because there's a lot of chronic conditions and things that you'll see, injuries that develop as a result of poor posture. So understanding what the posture is, what good posture is, and what that looks like, and how to identify poor posture, and then how to fix it are all really important concepts. So at the beginning here, posture in general is just the position of the body at any given point in time. So whether it's good posture, whether it's bad posture, it's still your posture. So that's what you have at that time. The reason posture is so important and good posture is so important is because that's what your body is biomechanically made to do. If your body is in the correct alignment, the way that it's designed to be in, it's able to handle forces a lot easier. We'll get to the upper extremity and what's going on in the shoulder and the scapula. Simple things like forward shoulder posture can really affect how the shoulder works anatomically and how injuries can result just from having forward shoulder posture. So good posture is natural, it is important, and the reason it's so important is because it's able to decrease those abnormal stresses that are on the body. That's how your body was designed to be, so we really want to make sure that it's in that alignment. It's able to handle a lot more. If you're in poor posture for a long period of time, you're going to end up putting a lot of stress on different parts of your body where it's not supposed to be. The term ADLs, activities of daily living, we use that a lot, especially when you're in the rehabilitation clinic with general population. But we'll say ADLs here as well. But that is just a term that is commonly used. Because the body is all linked together, it is part of a kinetic chain. When you change the anatomy or the makeup or the biomechanics of one joint, there's a good chance it's going to affect other joints along the way or other structures along the way. So for example here, how things can really build from just having poor posture, having that forward shoulder posture. Yes, that in itself isn't that big of a deal. No, you're not sitting up straight. No, you might not look as good as you want to, but in the grand scheme of things, forward shoulder posture is not that big a deal. But when you start adding other things to figure out what's going on here, the reason we might have forward shoulder posture, whether it's the cause or the effect, could be tight pectoralis minor muscle. Now, if you know your anatomy, the pec minor is under the pec major on your anterior chest. It starts on your rib cage and it goes up and it actually attaches to the coracoid process of your scapula. And what its job is to tilt the scapula anteriorly. So the scapula is on the back. It's supposed to grab it and tilt it forward, as if you were going into a forward shoulder position. That's what it's meant to do, but if it's tight, it's going to be doing that all the time. So forward shoulder will let us have tight pectoralis minor, which makes us move the scapula forward, which changes the position of the scapula. And if we do some sort of overhead, if I'm a pitcher or a volleyball player or a tennis player, baseball, softball player, and I'm actually doing overhead activities and I have forward shoulder posture, there's a really good chance that I'm going to develop some sort of chronic shoulder pain. So this is how we can see the link between just posture. Why is posture a big deal? Because it's going to end up leading all the way down to this chronic shoulder pain. And when I talk about posture, it's not good enough to just talk about, oh, you have chronic shoulder pain because you have forward shoulder posture. The next step is going to be to fix it. So we need to figure out why they're getting this shoulder pain, what's causing this forward shoulder posture, and then actually fixing the problem and preventing the injury from happening again. Remember, I said a lot of chronic conditions, if it hurts, don't do it. If you stop doing the activity, it will start to feel better. But if you wish to continue that activity, then you need to deal with the underlying problem, which is the postural issue. So like I mentioned before, the body is a kinetic chain. It is all connected. Depending on the position of the body, we can consider it open kinetic chain or closed kinetic chain. When you are in open kinetic chain, you're usually in a non-weight bearing position. And when you are in the open kinetic chain, you have the joints move more individually. There's less reliance on one joint, and it will not affect other joints near as much. In closed kinetic chain, this is a weight-bearing position, so when one joint, especially distally around the feet and ankles, if a joint down there is in a strange position or moves position, it will also affect all the joints up the extremity. So if I have, a change in my, my arch height, that's going to change my ankle position, my knee position, and my hip position all the way up if I'm in closed kinetic chain. So if you look at these pictures here, in both of these pictures, the foot is in pronation. Pronation is where you actually flatten the foot, where the arch is actually closer to the ground. In this position, they're sitting on the table, so the pronation is really only affecting the foot and ankle joint. There really isn't much effect on the knee or the hip because we're in open kinetic chain and it doesn't go up that high. So this is what pronation looks like in an open kinetic chain situation. But down here, this person is standing. They have moved into pronation, or having that flat foot, and you can see that it's going to affect the joints all the way up. So the foot is pronated, the tibia internally rotates, the tibia is connected to the knee, so the knee internally rotates, and the knee or the tibia and the femur are connected, so that means the hip internally rotates. So just when we're in closed kinetic chain position, just because you have one joint down here at the bottom is affected, it affects all the way up the chain. Where in open kinetic chain, it really only affects the joint it's connected to. When it comes to the upper extremity, which is what we're focusing on, there are less times when we are in closed kinetic chain position. Really, it's the only time we're going to have. It's only going to be when our hands are actually contacting the ground. So if you're in a push-up position, or you do dips, or things where you're actually putting weight on your hands, you might see it more in dance or in gymnastics. Traditional athletics, ball sports, stick sports, those tend not to be very often upper extremity in closed kinetic chain positions. Okay, so a big concept here I really like and I really like to talk about is the idea of the muscle length tension relationships. Your muscle is going to be, any muscle in the body is going to be, is going to have advantageous positions. There's some parts of the range of motion that are really easy because your body's in a good position. There are some parts that are going to be a little bit harder. So basically, the amount of force or tension you're able to produce in the muscle is based on the length of that muscle. So not the length of the entire thing, but how much that specific muscle is stretched out. So I'll get into all that. Hopefully you guys understand the makeup of a muscle. The sarcomere is the smallest unit in a muscle. It contains the actin and the myosin. And again, hopefully you guys know this. If not, you're going to need to ask me questions later on. With the actin, they're the specific strands. The myosin have the heads that actually grab onto the actin, and that's where the actual shortening occurs. So like I said, the position of the muscle is going to really determine how much force it's able to exert. So we have a couple different terms here, and it's all based on the positioning of the muscle. So all these line up. So down here, these pictures are actin and myosin. These top pieces, all these little circles together, those are going to be your actin strands. The dark black ones with the circles sticking out of them, those are your myosin. Myosin go up, grab onto the actin. When the ATP are released, they're able to pull this entire sarcomere closer together, and that's where you have the shortening. This is all about concentric contraction right now, so the shortening of the muscle. This again is going to tell us how much force is being produced. So based on what each individual sarcomere looks like, it can tell us how much force we can produce at that angle. So during this resting state right here, this resting state is when the muscle is at mid-range. So in this case, we're going to look at elbow flexion. We'll say it's the bicep brachii. This is a sarcomere from the bicep brachii. When we're at mid-range, so he's at 90 degrees, we have a lot of overlap between the actin and the myosin. So when the myosin go to grab up, they're actually able to come up here and grab on, and almost every single myosin head can grab on to every single actin. So we have a ton of overlap so that all the myosin head are actually working and they're doing something and they're going to help shorten. That's where we're going to be the strongest. We are strongest in mid-range. So think about when you're carrying your groceries in and stuff, you tend to carry them in your arms at around a 90-degree angle. You are stronger at that 90-degree angle. It is just because you have the most actin and myosin overlap. Then if we go the opposite way here, we'll go all the way flexed. So in this position, he is all the way flexed, all the way in the elbow flexion. And this is a pretty weak position for us. If we actually measured from this position how hard he can pull from this far down, it's going to be a lot weaker than in this position. It's because there is very little myosin actin overlap. They're too far away. So the myosin heads in the sarcomere aren't able to reach up and grab. I mean, you have all these myosin here, but there's no actin to grab onto. They're already overlapped. So they're too far away from each other. So because there is very little actin and myosin overlap, there is going to be lower force production. That's called active insufficiency. Active insufficiency is when we have too much overlap and we're not able to have as strong of a contraction. And then the last one is passive insufficiency, and this is when your arm is all the way extended or in the longest position. Unlike active, where there's too much overlap and they can't reach, this time we have too little overlap, and they're not able to reach. So we still only have a couple myosin heads reaching the actin, and all the rest of these myosin heads can't reach any of the actin because it's too stretched out. So in this position, we're also very weak. My best example of this is if you've ever tried to use a bicep curl machine in the gym, and you put your weight in, in the stack, and you stand up, you put the weight in, you grab the bars, your arms are all the way extended, the back sides, your triceps are resting on the pad, arms are all the way out, and you try to curl. If you've done the machine, a lot of times you're not able to actually get that curl. You're not able to get it started. So a lot of times what I do, I just stand up, bend my arms, get it started, sit back down. Now my elbows are bent, and now I'm able to do that curl. But I was not able to get it when my arms were already all the way extended because I was not strong enough. I was strong enough here in mid-range to handle that weight, but I was not strong enough at end range to handle that weight. So the same kind of thing is going on in this picture. What I just explained is depicted in this length tension curve. So what we have here is this, again, same information. Down here is the length of the muscle. How long, how much is stretched out. So down here, it's not stretched out very much at all. Down here, it's all the way stretched out. And then this line is showing you how much force can be produced. So we're looking at the length of the muscle and how much force it can produce. The first one we talked about was mid-range. Mid-range is where we have optimal actin and myosin overlap. So in here, we are the strongest. We can produce the most force. And because the muscle is not stretched out, we have a ton of actin and myosin overlap. The next one we looked at was active insufficiency. In this case, I should have switched those. In this case, sorry, hold on one second here. Sorry, we're going to switch these. Active and passive, those are backwards. So down here, the muscle is all the way lengthened. That would actually be passive insufficiency. Let's see if I can do this. Because the muscle is all the way stretched out. We are not able to produce that much force because it is too stretched out. There is not enough actin and myosin overlap, so low force is produced. Then over here we have our active, where this is at end range, where there is too much actin and myosin overlap. The muscle is too short, and we're not able to produce enough force, or not able to produce a lot of force because there is too much overlap. So our active, our resting state or mid-range, and our passive insufficiency, this helps determine, helps just depict what that means from the previous slide. I really like this this curve. I use it a lot. I'll reference it a lot. I'm pretty sure you'll have to either draw it or explain it on the test, but it's the idea of looking at the length of the muscle and how much force is produced, and it's all about how much actin and myosin overlap that there is. A couple terms here. We have our agonist muscle. This is the muscle that actually contracts. It performs the primary movement, so whatever activity you're doing, the agonist muscle is the one that's primarily performing that activity. The antagonist muscle is going to be the opposite muscle or muscle group of the agonist. Pretty much every muscle in our body is going to have an opposite. So whatever we do multiple motions. We tend not to move in just one direction. If we can do flexion, we can usually do extension, or we need to at least bring the body part back to where it started from. So we need muscles to do that. So there's usually pairs of muscles within our body. So then we have reciprocal inhibition. This is a really important concept, and it's going to not only come into play in this class, but also it'll come into play big time in rehab next semester. But reciprocal inhibition is defined as the antagonist muscle reflexively relaxing to allow the agonist muscle to occur. So basically it's saying if we want to do elbow flexion, and we want the bicep brachii and the brachialis to do elbow flexion, the triceps have to relax. So the nerve systems are actually set up. If I'm going to do elbow flexion, that means my flexion muscles are going to contract and my tricep extension muscles have to relax. So it's just in order for us to have motion to occur, one side's got to work, one side doesn't. So that is actually determined by, it is a nervous system input. If both muscles did contract at the same time, that would be the next definition, and that's your co-contraction. This happens when both muscles contract at the exact same time. If we have the agonist and the antagonist muscles both contracting at the same time, no movement will occur. Force will still be produced, but it will end up being an isometric type contraction because we'll have force coming from the flexors and the extensors, and little to no movement will occur, but force is still being put out, just the joint will not be moving. All right, then this is a really important concept, this next this slide right here, because not only does it help you determine that the person has a problem by looking at their general posture, it also can help you try to figure out what is causing the problem. And if you know what caused it, then you know how to fix it. And that's a really important concept. So basically in our body, and especially here in the low back region, in pelvic region, where we're going to be focusing on this slide, is very prone to injuries. And we're going to end up seeing a lot of postural deviations to the lumbar spine that are based on tight muscles and weak muscles. And luckily for us, they work in somewhat of a predictable pattern. They actually, you draw a big X across here, and we're looking at the pelvis, and we're looking at the low back. If you know your anatomy, if not, learn it. We have our pelvis here, and our pelvis on each side are joined together by the sacrum. The sacrum is the middle part, the middle bone in the back of your body. And the top of the sacrum is actually connected to L5. It's the last lumbar vertebrae. And then L5 to L4, L4 to L3, and all the way up. So everything's connected. So the entire spine is connected together. Then the spine hooks to the sacrum, and the sacrum hooks to each of the pelvic bones. So it's all one piece. If one is going to move, they're all going to move. So it's not, the pelvis is going to move when the low back moves. They're going to all work together as a unit. They're not going to be separate pieces. So the next step then is understanding your anatomy. Back here, we have, we'll call them just general right now, back extensors. Their job is to extend the spine. In the front, we have our abdominal flexors. Their job is to flex the spine. Down here on the pelvis, we're going to have our hip flexors because they're going to bring the hip up. And then in the back here from the ischial tuberosity, those are our hip extensors bringing the hip or leg backwards. So when we start to see problems here, we're going to see them kind of grouped together. So if we look at this person and let's give them a little bit excessive lumbar lordosis. So now this is our new spine right here, lumbar lordosis. In order for us to have this increased lumbar lordosis, we have to also have our pelvis tilting forward. Because in order for us to get more of a curve in the lumbar spine, the pelvis again is connected. So if the lumbar spine is going forward, moving this way, then our pelvis has to also adjust, and in this case it's going to tilt forward. So an increase in lumbar curvature, which is what this anterior curvature is going to be associated, or at the same time you're going to get an anterior pelvic tilt. More anterior pelvic tilt. So here's your pelvis. This is the ASIS right here, which is the most prominent point. It's going to end up tilting forward and kind of down and around like this. And then the back of the pelvis is going to rotate that way. So it's just going to rotate kind of in a circle. It's not going to really move up and down. It's going to rotate. So altogether here we have now, this person comes in, they're going to have an increase in lumbar curvature, and they're also going to have an increase in pelvic tilt. Those two things are always going to go together. If we saw someone who had a decrease, let's do it on this guy. If we had, let's say, flat back and a decrease in lumbar curvature, in this case we're going to have a posterior pelvic tilt, because it's going to go opposite. So in order for us to get this flat, we're going to have to rotate the pelvis backwards. So that's going to be your flat back. This is your increased curvature. So we'll stay over here to our increased lumbar curvature. This is going to be a result usually of muscle problems. So we're trying to figure out how to fix this. When this person comes in, you're going to be like, whoa, that guy totally has lumbar lordosis. So what? That's easy. Anybody can figure that out. What we want to figure out is, how do we fix it? Well, the first step is to identify which structures are tight and which ones are weak. And we can do this by determining, based on this posture, what do we think is tight? So in this case, because we have an anterior pelvic tilt, we have an exaggerated anterior pelvic tilt, we know that we have a rectus femoris here and we have hip flexors here, that their job, and they're in the front here, they're going to be a little bit tight because of the anterior pelvic tilt, the rectus femoris and the hip flexors are going to be a little bit tighter. They're going to be shorter and tight. We also know the pelvis is heading upward in the back, and at the muscles that are attached there, your spine extensors, are also going to be tight. So somebody with anterior lumbar curvature, excessive lumbar curvature, lumbar lordosis, is going to have tight hip flexors and tight back extensors. They're going to be pulling up. These guys are going to be pulling down. That's why this line is drawn here. There's an X. So these two across this way are going to be tight. So if those two are tight, then that means these two groups are going to be weak. We have our abdominal muscles pulling up this way, and we have our hamstring muscles pulling down this way. Those are going to be weak because their job is to pull down, but because they're not working correctly, they're letting the back extensors pull harder. Your abdominal muscles are not strong enough to compete with the tight hip flexors. So this is where you get kind of your belly sticks out, where you, not fat, but just you can see that it's more protruded. You have a very strong curvature in your back because those muscles all go together. All right, let's erase this and try it again. See if I can do it. Nope. Oh, there we go. This is a really important concept, but I'm going to talk about it over and over and over again, so it's really important to try to remember this. So if someone comes in, and we'll just leave it as like this is, but we'll say this is anterior pelvic tilt, this is lumbar lordosis. Remember that there is always a line that goes through, and the same muscles on that line are going to be either tight or weak. So in this case, if we say that it's from anterior pelvic tilt, that your hip flexors are going to be tight and your back extensors are going to be tight because they're causing the pelvis to rotate this way. That also means your abdominal muscles are going to be loose and your hamstrings are going to be loose or lengthened because they're not able to resist the force. So if this was my patient and I see them come in and they have lumbar lordosis, I know that they have tight hip flexors, tight back extensors, weak abdominals, and weak hamstrings. So what am I going to do? Stretch the tight ones, strengthen the weak ones, and also assess the general postural idea, but that's how it's going to work out. So again, this is a really important concept. We'll talk about it again in class, but and please, if you're not understanding that, make sure you ask questions in class. General postural stuff now, the actual exam part. Ideally, we're going to use objective tools if possible to give us the most precise idea of posture. Posture tends to be very subjective, where as clinicians we like to be objective. We want numbers, we want stats, we want measurements, we want range of motions, we want real things. But a lot of times when you assess posture, you're just looking at it. As an examiner, yes, you're trained, you know what you're doing, but it's still kind of your opinion. So if possible, just like anything else, we want to use objective tools, whether that's x-rays, which we don't have access to, we have to refer, any kind of photographs, computer analysis. We'll do this next semester, but we will actually start recording people, because before it was difficult to get access to a video camera, get the right size tape, get the right device to read it. Well, not everything is digital, and every single cell phone that everybody has a recorder on it, has a video camera on it. So there really is, it's easy for us to get video footage without doing much work. And that is a really more objective way to look at someone, because you're able to stop and actually freeze the frames and go through it slowly to understand what's going on. Other tools that we're going to use in class or in lab, we're actually going to be using plumb lines. A plumb line is a string with a weight at the end of it, and its job is to hang perpendicular. That's it. Because it's going to be a known reference point. We know that that line is perpendicular. So when the person stands against it, we can see if they're leaning one way or the other because we have a reference point. There are also goniometers we can use, and then inclinometers is this thing over here. We have a couple of those that we'll use because the spine is very difficult and there's so many pieces to it. It's really hard to use a regular goniometer. So this is able to assess range of motion by using gravity and fluid. So it's because it's got liquid in there. It's kind of like a level where it's going to stay in one position. You move your body through the range of motion. Like I said, because posture assessment is relatively subjective and it's based on who's doing the assessment, it tends to not, if you're not able to measure, we tend to describe the problems as mild deviation, moderate deviation, or severe deviation, because it gives us, it's not as specific, but it can still give you a way to grade the problem. So if you have a minor postural deviation, that's less than 25%. It's about 25% from normal. If it's a moderate deviation, it's about 50% different than normal, and severe is 75 or higher. That's kind of the range when you're actually trying to grade the severity of the dysfunction. But again, if we're able to, try to quantify whenever possible. When you are starting to assess someone, we don't really want them to know that they're being assessed. Now, obviously, you can't hide the fact that you're going to assess their posture, but you kind of want to, at least to distract them. What we try to get them into what we call ortho position. This is what their normal posture is. We don't want to say, okay, I'm going to assess your posture, and the first thing everybody does, even in class, the first thing you do is sit up perfectly straight. Well, how long does that last? That's not your normal posture. That's not your normal standing posture, whatever it is. We don't want them to be in good posture. We want them to be in their posture. So we try to get them into ortho position. And we can do that by kind of making them relax a little bit. So or move around, not thinking about what they're doing. So we can have them march in place for 10 times, roll their shoulders, roll their neck, inhale, exhale deeply. You can talk to them, get them distracted, where they're still standing still and standing, but in their normal posture, not in what they think is good posture. There's no point in us in doing an eval on them when they're standing in good posture. That's not what they normally have. All right, we'll stop there, and I'll continue this on the next one.